Okay, demo of the FPGA of project 4, which is SWI3S manager and 2 peripherals on the same FPGA board. And so here we are, it's write bitstream complete. So the next thing, we just do program device. And it's being programmed, and it's programmed. We have picoscope connected already. I'll show it later. And now what we see is we get continuous Arasan. Let's ask just the version number. I didn't update it, so it's 16 May 2026. But what I can do now is include sample size 6 sequence of commands that go into the UART. The whole communication with the board is through UART, and it appears to be slow, but the slowness is because of other constraints. So what we see is we're filling manager registers, and then through manager registers sending CDS commands to the board. It takes a while because the sequence, in reality, of course, it's much faster. But here I slow it down on purpose. Okay, so this sample size 6 is exactly the same as the test in TB in the test bench. It was, of course, modified a little bit, but that's to adapt it to FPGA. And whoa, now what you see is the speaker PWM. For FPGA, the output of speaker is PWM on certain pin, which can be found in XPR in the XDC file. And you see, basically it emulates a sinus wave. The microphones are just producing sinus wave samples, and they go through 2 peripherals from microphone to the speaker. The speaker is modeled by PWM output, which we see here. If we well, that's pretty much the same, but you see the breathing of the PWM. Now oh, sorry, a few words about how the FPGA is built. Well, basically we put a manager and a couple of peripherals on each FPGA. Here it's shown just one peripheral. The microphone and the speakers are mock-ups, and a few other notes. So this just notes how parts of DN clock are generated in the FPGA, but that's about it. Now let's see how the FPGA board looks like. So here it's the FPGA board, and you can see that it is connected through UART to the Linux box. There is a speaker here, but it's too weak the FPG output is too weak to hear something reasonable. What we see here is that we can select which speaker PWM goes out. Not all of them are activated in this test. So for example, here we see that it's not a speaker, it's a DN clock. And if we select something else, let's see what it's 7. It's another speaker. Of course, it's not a real speaker, it's PWM. And so on. There is more outputs which are available here, can be selected. The 4 of these switches control what internal signals are presented as a 8-bit bus. Here we see 23. In fact, it's the number of slots in one line. I don't know what this is. There's 2 versions, one is next and one is current. So now if we press reset button, we get to the reset state where the number of slots in the line is 2, which is the initial state. And because I pressed that button, there is no PWM activity. To restart the activity, I need to enter talk PY. And once again, it's Arasan greeting. Just a second. And now we include the test again. Sample size 6 sequence. It will take a while. Yeah, what is it? Interesting. Okay, it's some very high speed output coming out. I guess it's... Oh, that's some default value. Now this is a DN clock. So if we come here, there's still 2 slots in one line. And now it started the real traffic. And if we put here 5, I guess we'll see PWM again. Yeah.